Hello, this is Mrs. Dehn-Brastad, and we are going to continue our work on Chapter 13 with Section 2 on angles of rotation. Our objectives are to draw angles in standard position and to determine the values of the trig functions for an angle in standard position. So remember that in the last lesson we investigated trig functions by using acute angles in right triangles. But we can also find trig functions for other types of angles. It doesn't have to be in a right triangle. So we're going to be using the coordinate system, with our x and our y axis. And an angle is in standard position when its vertex is at the origin and one ray is on the positive x-axis. So here's the positive x-axis from here to here. The initial side of the angle is the ray on the x-axis. The other ray is called the terminal side of the angle. For example, maybe we would make an angle right here and call this angle theta. So we've got the initial side here, and we've got the terminal side here, and that is how we created our angle. And then you can draw straight down and make it into a right triangle so that it looks more like what we did in the previous lesson and what you may have learned before. So you can just draw straight down to the right to the x-axis, or you can draw straight up to the x-axis. Now this one, your right triangle is going to be made with, you'll be using 180 minus the angle given. This was a 135-degree angle. In this example, our angle was negative 45, so we went down 45. Our initial side is on the x-axis, and our terminal side is the other angle, the other ray used to form the angle. So you can either go positive rotation or negative rotation. If we go positive, plus 390, we start here, and we would go, remember there's 360 degrees all the way around, so here's 90. Here's 180, here's 270, here's 360. We have to go 30 more to get to 390 because 390 minus 360 is equal to 30. So this would be a 30-degree angle inside there. If we go, that's counterclockwise. If we go clockwise, then it's a negative rotation. And you can go more than 360. You could go 720. You could go 1,000 degrees. You just keep going round and round and round. So a 360 is a complete rotation. 180 degrees is a half of a complete rotation. So let's see, how would we draw an angle with the given measure in standard position? So the first one is 320 degrees. So what we're going to do is start with your coordinate system, start on the x-axis right here, and go 320 degrees. So you can count. There's 90, there's 180, there's 270. So I always would say, okay, I'm at 270 right here. How much more do I need to get to 320? So 320 minus 270 is 50 more. So I had to go 50 more degrees, which is a little more than halfway from here to here to draw my terminal side here. And then for 110 negative, again, you start with your XY coordinate system, and this time we're going to go clockwise. We're going to go the opposite way. There's 90, and then we have to go a little bit more to get to 110. We have to go 20 degrees more to get to 110, because 90 plus 20 is 110. And then 990, that's more than 360, so we're going to go around a couple times. So we start on the x-axis, and we go, there's 360. Now we're going to go around again right here. That's 720. How much more do I need from 990 to from 720, which I already went to get to that point right there? I still need 270 more. So I go 90, 180, 270 brings me right exactly to that point. And then you would draw your terminal side, which ends up being right on the y-axis, so it's hard to see, but there is a ray there. This is just some more practice, so sketch these on your paper and see if you get the same result. So 210 degrees would be just in the third quadrant there. Remember, this is first quadrant, second quadrant, third quadrant, and fourth quadrant. If I say what quadrants it's in, those are the numbers. So 90, 180, plus 30 more to get to 210. This would be 30 in here. We'll do that later in this worksheet. 1020, 1020. So we have to go round and round and round. So in this one we went 360, then we went around again, 720, and we didn't have to go around a whole third time, but close. We had to go 300 more. So there's 90, 180, 270, plus 30 more to get to 300. So this in here would be a 60-degree angle if we need to know that. And then you draw your terminal side. And then negative 300, remember for that one you're going to rotate the opposite direction, and we actually end up back in the first quadrant for that. So you go around 90, 180, 270 plus 30 more. This would be 60 if you need to know that, and then that's your terminal side that you're going to draw. Now how are you going to do this in Word if you're not printing your worksheet out and doing it by hand? Here's how. So I'm just going to scroll down to where these are on the worksheet, which is about right here. So to go to 150, now I have a pen tool, so I could use it to go around, but most of you probably don't. So that would be 90, and I don't have to go all the way to 180. So you're just going to do that with your finger, and then you're going to say, okay, I need to have it over here about there. So on your Word document, let me move this over, go to the Insert, then go to Shapes, and then get the arrow, the line that has one arrow on it. And you're going to start at the origin, and you're going to go this way. And you can, figure out exactly where it would be, do your best estimate. I know that I only needed 30 more degrees to get to 180, so I'm going to say it's about there. If you want to change its color, you can, but you don't have to. You can just leave it at the default. Mine keeps going to blue. I don't know why. And that's all you have to do. So for negative 330, didn't we do that one? I'm going to start at the x-axis. I'm going to go around 90, 180, 270, not all the way to 360, because that'd be too far. So it's going to be right about here. So I'm going to insert my shapes, and then I'm going to get that ray tool, and I'm going to draw that. I didn't start very good there. I'm going to try that again. Insert shapes there. Okay, so I'm starting at the origin. Yeah, it still isn't exactly at the origin, but that's okay. That's the idea. And if you want to move it around after you can, maybe then you'll get a better. Sometimes it's impossible to get it exactly where you want it, and that's okay. This is just a sketch. That's a good enough sketch. Okay, so you'll do that. You don't have to draw the little angles of a rotation. I have seen people do it. They use these curvy line things. Let's try it once just to see how it works. So negative 585, I'm going to go around. Yeah, I can't do it. It's too hard. Maybe it was the other one. This one? Nope, I can't do it. It's too complicated for me to even try that. So just figure out using your finger where it's going to end up. I'm making a spiral, but it's terrible. I don't know how to get out of it. And then put your line where it would end up. Okay, so going back to our PowerPoint here. Coterminal angles is another term that we need to know. They are angles in standard position with the same terminal side. For example, angles measuring 120 and 240 are coterminal because they end up in the exact same spot. If you start on the x-axis, which you have to do, and go 90 plus 30 more, you get 120, which is right there. If you go negative 240, here's negative 90, here's negative 180, and here's 60 more, which also ends up in the exact same spot. These two are coterminal. They will have the same results. They'll be in the same place. There's, of course, infinitely many because you can just keep adding 360 and multiples of 360, or you could subtract 360 and multiples of 360. So you're going to be doing this on your worksheet. You're going to be finding the measure of a positive angle and a negative angle that are coterminal with each given angle. Now you could sketch these, but you don't have to. You just have to add multiples of 360 or 360, or subtract 360 or multiples of 360 until you get one positive, one negative. So the most simplest ones are where you just have to add 360 and subtract 360 from the original value and get a positive and a negative. Sometimes, however, you have to subtract more than one or add more than one. For this one, to get a positive, I can just subtract 360. I don't have to add and get a huge number. I could subtract and it's still a positive coterminal angle. In order to get a negative, I'm going to have to subtract 360 twice. So 410 minus 2 times 360 in order to get a negative. So when you do your worksheet, make sure you're getting one positive and one negative, not just always adding 360 and always subtracting 360. Here's the problems from your worksheet. Number 7 is an example where you can actually subtract 360 in order to get a positive value, but you're going to have to subtract multiple 360s in order to get a negative. Like I said, you can try 3 times 360. I don't think 2 times 360 is 720, so if you only subtract 360 twice, you'll still get a positive, so you'll have to keep going. Let's look at number 9. If I added 360 to this, I would still have a negative number. So I have to add 2 times 360. So I have to take negative 370 plus 720 in order to get the positive value. To get my negative value, I can just go ahead and take negative 370 minus 360. That's certainly going to be a negative value. So you can work with these remembering that sometimes you have to add or subtract multiples of 360. Just make sure that you get one positive and one negative for each of these problems. All right, finally we're going to get to reference angle. We will be using this quite a bit in the future in order to find trig values of angles of rotation. So the reference angle is always formed with the x-axis. It's with the terminal side and the x-axis. So you are always going to go down and get to the x-axis, and then we want to know what is this angle in here. Now they called this theta, so I have to call this something else. I'll just call it A for now. And I need to know the measure of that angle in order for me to use sine, cosine, and tangent with a right triangle. You know, this will be a right triangle here. All right, so here's some general guidelines. If you're in the first quadrant, then your theta equals your theta prime, which is what they call the reference angle. So it's going to be equal. So if you're between 0 and 90, that angle is going to be the same as what you're going to use. If you're in the second quadrant over here, if that's where your terminal side ended up, then you're going to take 180 minus this angle. Like let's say this was 145 degrees. You take 180 minus 145 to find what this measure is. If you're in the third quadrant, you will take that angle measure minus 180 to figure out what this angle is. Or you could go 90 plus 90 and then 270 minus that degree and add them together. But this is the shortcut way. And if you're in the fourth quadrant, you just have to take 360 minus the angle that you were given in order to find the reference angle, which they're calling theta prime again. So they just write a theta with an apostrophe after it, and that's theta prime. But you could also give it another letter like I was doing on the earlier page, like angle A. So it'll always be an acute angle less than 90, and you always form it up with the with the x-axis, or down with the x-axis. That's the angle we'll always be looking for. That's called the reference angle. So let's find the reference angle for 135. So we start by drawing our 135 and do this even on scratch paper or somewhere. Get an XY axis and go, there's 90. How much more do I need to get 135? And then you're going to be, remember, sketching this down So we're going to be looking for this angle in here. So you take 180 minus 135, and you get that this would be 45 degrees in here. So the reference angle is 45 degrees. In the second one, it's a negative rotation. So we always start on the x-axis, and you go 90, and then you need 15 more to get to 105, and then you sketch it, and then you're looking for this angle in here. That's your reference angle, is inside. It makes your right triangle with the x-axis. So to find that, you can take, I'm going to look at the little formula they had for that one right here. When it's in the third quadrant, you take the angle you were given minus 180. So the angle you were given minus 180. But you have to do the positive, I guess. But the reference angle would be 75. I can't erase. Well, that would be pen. There we go. Okay, so 75. So if this is 75 and this is 105 from here to here, then 105 plus 75 is 180 from here to here. Okay, here's our 325. That is starting at the x-axis, of course, going all the way around until we get to not to 360. We have to stop short of it. And to find out what the measure of this angle is, just take 360 minus 325, and it's 35 in here. On your worksheet, you have several of these to do. Let's just look at a couple. Let's start with 13, 212. So start on the x-axis and rotate around. So there's 90, there's 180, and it's going to end up down here somewhere. So let's say it's here. Now I have to find what is the measure of this angle. So formed up with the x-axis, what is the measure of this angle? So to find out, you're going to take 212 minus 180. So 30, it's hard to read my own writing, 32 degrees. So this would be 32 degrees. So you don't have to put positive or negative. These will all be positive when you do your reference angle. Now let's try one that's negative, like number 14. Theta is equal to negative 115. So this time we always start here. We start on the x-axis, and we're going to go, there's 90. Now I have to go more than that, and I'm going to end up, it's going to be in this third quadrant as well. And I have to figure out if I had gone, and you still form it up. So 180 minus 115 is 565. So this one would have a measure of 65. And you can check that. If I had the 115 plus 65, would I get all the way back up? Would I go 180 degrees? Yes. So this angle would be 65 degrees. If it's more than 360, that just means you go around more than one time and see where you end up. So again, you always start here. I would be going around 1, that's 360. 2 gets me to 720. And I need just a little bit more because I was at 720. I only need 20 degrees more for my reference angle. So I'll be in the first quadrant there. And you'll do the rest the same way. Okay, finally we are going to determine the value of the trig function. So once we get it in standard position, like we just did, now we're going to write the sine, the cosine, the tangent, and so on of all of those, of that triangle that we get. So we're going to have to use Pythagorean theorem to find r, which will be the hypotenuse, and then we'll just use sine, cosine, and tangent. All right, so here's how we start. We start by putting this point, they're going to give us a coordinate point, we put it on our coordinate system. So we go over to -6 and then up to 9, and we put a point there. Now you draw a ray from the origin up to that point. Now we go straight down and we are creating this right triangle right here. So it's a right triangle. What is the leg here of my right triangle? It's 6 because I went over -6. I'm just going to use the 6 though. What is the height of my triangle? It's 9. So that's my other leg. I guess I'll put my negative. So -6 for this, 9 for this, and now we have to find the hypotenuse because otherwise how will we write the sine, cosine? We need the hypotenuse. So for that we will go 6 squared plus 9 squared. I mean, you can use -6 squared, but it's going to be 36 either way. And then we'll take 9 squared is 81, and we'll add those together, 117, and then take the square root of that, which simplified to 3 square root of 13. So this hypotenuse is 3 square root of 13. Now I have everything I need to find the sine, cosine, and tangent. I just use everything that's on my triangle. We're always going to have r be positive because it wouldn't make sense for it not to be. So let me fill this back in. We've got -6 here. We've got 9 here, and this was 3 square root of 13 for the hypotenuse. So the sine is equal to the opposite over the hypotenuse. So I don't even need this y and r stuff. It's opposite over hypotenuse, which is 9. This is the angle we're talking about in here. 9 over 3 square root of 13. Now you can simplify that by multiplying top and bottom by the square root of 13. It's called rationalizing the denominator. It's not considered simplified if you have a square root in the denominator. But the square root of 13 times the square root of 13 is just 13. So we're left with here 9 square root of 13 over 3 times 13. And 9 over 3 simplifies to just 3. So they just simplified that to 3. So 3 square root of 13 over 13. Now we have to do the cosine. So the cosine is equal to the adjacent side over the hypotenuse. So the adjacent side is -6, and the hypotenuse is still 3 square root of 13. So then we rationalize the denominator and simplify, and we get -6 square root of 13 over 3 times 13, but this simplifies because -6 over 3 is -2. So we get -2 square root of 13 over 13. And then finally we do the tangent, which is equal to the opposite over the adjacent. So here's our theta. Opposite is 9 over -6. No square roots in this one. And then we just simplify that to -3/2. Now it's even easier to find the reciprocals because you just flip these over. So the first one would be 13 over 3 square root of 13. And then again, we rationalize the denominator. So we would get 13 square root of 13 over 3 times 13, but the 13's cancel, so square root of 13 over 3. And then when we rationalize, when we flip cosine theta, we get square root of 13 over 2. And when we flip, this one's the easiest, -3/2 over, we get -2/3. So the negative stays. If they were negative before, they will be negative with their reciprocals. This one should be negative. They have a typo there. All right, let's look at one from your worksheet. This one's on your worksheet. So the point is -3/6. So I already drew that on here. I went over 3 and up 6, and I put the point. And then I drew a ray up to that point. Now I'm going to label my right triangle. This would be -3, and this would be 6. Now I have to find the hypotenuse. And that's easy enough to do. You're going to go -3 squared plus 6 squared is equal to 9 plus 36. That's the square root of 45. So 3 times the square root of 5. Now we go ahead and find, I need to put these back in, -3, 6, 3 square root of 5 is the hypotenuse. So the sine is going to, we're looking for this angle here. The sine is opposite over hypotenuse. So that is 6 over 3 square root of 5. And then when you rationalize it, you get 2 times square root of 5 over 5 because you multiply top and bottom by the square root of 5. 6 square root of 5 over 3 times 5, and then that simplifies to 2 square root of 5 over 5. And then we do the cosine, which is going to be the adjacent side over the hypotenuse. So negative 3 over 3 square root of 5. That simplifies to negative 1 over the square root of 5, which is the same as the square root of 5 over 5. And then the tangent is equal to the opposite over the adjacent. So this one won't have a square root in it. It'll just be negative 2. Negative 6 over, or 6 over negative 3 is just negative 2. Then for the reciprocals, it's easier to take the reciprocals before you rationalize the denominator. So this one was negative 1 over the square root of 5. The reciprocal of that is just negative square root of 5. In this one, here it was before we simplified it. It's easier to take the reciprocal there and get square root of 5 simplifies a little bit to over 2 than to do it after you rationalize. And the cotangent is the easiest one. The reciprocal of negative 2 is negative 1/2. And that's it. If you have any questions, if you need help, please let me know, and I will be happy to help you out. Thanks a lot and have a great day.